Good morning. This is going to be a video on some of our log properties that we talked about. Well, we talked about one yesterday, didn't get all the way through it. So this is just going to be just a real quick example video, and hopefully you will be able to understand these three log properties by the time that we are done, and you will be able to use them to solve exponential equations. Okay, so we have three log properties. The first one we talked about yesterday. This is a scenario where if there is an exponent inside of the log, so this is like the Rx is being acted on by the log, okay? So if we use logarithms mainly to move something that is in the exponent, a variable that is in an exponent outside, because we cannot solve if our variable is in the exponent normally, okay? So what we can do is we can say that this log Rx, what happens with logs is that this x, whatever number is in the exponent here, gets moved out in front. So it gets taken away from our base here, and that exponent is going to come out in front. So it's going to be log Rx becomes x log r. This is x times log r. Okay? So that is the first property that we're going to refer to, and you will be using that one probably the most out of all of them. Okay. The second one is the scenario where it is the log of two numbers being multiplied by each other, so log of x times y. And what happens with this one is basically you can separate them, and because it's being multiplied here, you end up adding the logs together. So log of x times y becomes log of x plus log y. Okay. So it's sort of like with exponents when you have two things, like if you have x squared times x cubed, right there, this becomes, we add our exponents together and we get x to the fifth. So it's kind of the same concept here because it's related to exponents. When there's multiplication occurring, we are actually going to add the logs together. Okay? And just the opposite, if we have a log of a quotient, so if we have log of x divided by y, instead of it being addition here, it's going to be log x minus log y. And this is the same thing as if you had x cubed over x squared. This is going to equal x, well, it's going to equal x, but it's x of 3 minus 2, which is again just x to the 1. Okay, so the same logic that you do with when we are dividing exponents is the same thing with logs. We're going to do log x divided by y becomes log x minus log y. And in that way, we're able to split them into individual things that make it easier sometimes for us to manage them. Another thing you can think of is these work both ways, so you can go from here to here, but also if you see something that's log x minus log y, you should be able to go backwards from them. So for all three of these work backwards, so you can go in either direction. With more practice, hopefully that'll just become something that is more second nature to you. Okay, so I'm going to do one example for you guys, and then you guys can do the practice problems that are listed below. So I have a log. It is the log of x cubed times y squared all over z. Okay, so I need to figure out how I can simplify this so that it is not, so I have a log for each one of my variables, and so that it is in its most simplified form. Okay, so there is multiplication going on here on the top. There is division going on here on the bottom. So I'm going to do the division first, okay? So I know that if I have something divided by something else, that there's going to be subtraction going on. So I can say that it's log of x cubed y squared. So just like this, in this case, the x cubed y squared is functioning like my x here, okay? Since it's being divided by the z inside of the log, I just have a log z over here, minus log z. Okay, so right here, this actually is in its most simplified form already. This log z is going to stay with us the whole time and it's not going to change. Okay, now I have the log of two things being multiplied by each other, which means I'm going to use my second property right here, and I'm going to split them up into two separate logs. So one that has a log x in it, one that has a log y. So it'll become log of x cubed plus log of y squared minus that log of z. Okay? Now we are almost done. So we have actually worked backwards. We first used this property, we used this property. Now we're going to use this property that allows me to move my exponent down in front of the log. So I have log x cubed. My exponent moves down in front using that log to make it simpler. It becomes 3 log x. Okay, the 3 has come down in front, and we take it away from the x. We can do the same thing with this log y squared. It becomes 2 log y minus log z, and we are done. So we have simplified it all the way so that we don't have any exponents inside of our log, and so that each log has only one variable in it, okay? Normally you won't actually encounter problems where you'll have 3 variables like that because you guys don't know multivariable things like that. So, but there will be situations when maybe there's 1 or 2, and especially on the SAT, they might ask you questions like this. In our class, so much you won't see too many like this, but on the SAT, you might see a problem that requires you to use some log rules. Okay, so this has been a little intro video on log properties. These are the main ones. It works the same with log base b. So if it was log 4, it works the exact same way. Same thing for the natural log. So if we wrote ln instead of all of this, it would be the exact same thing.